Hi, I'm Mike Rudolph from MathWorks, makers of MATLAB and Simulink. Whether you're working on subsystems and components all the way up to the mission level, MathWorks Tools provides comprehensive capability for you to go all the way from requirements through system architecture, all the way through your design and test and implementation. And the beauty of the environment that we offer is the ability to simulate your system architecture and design all the way through the course of the program. We have a whole host of products that we can support MSO workflows to be able to test and validate against realistic clutter and interference environments, whether you're doing scenario modeling, propagation modeling, front-end design, many different products that support a whole team's capability to test, validate, verify, and reduce risk earlier on in the program so that once you get to your hardware implementations, you feel much more confident about what you need to test out in the field and how you can look for corner cases to validate and verify those additional capabilities. So model-based design is really well suited for doing that, and we'll show you with a couple of our demos. So as you go all the way through prototyping, implementation, into hardware, a whole team can work together on these various complex systems. And let's talk to Leif and give you a sense for how teams might be collaborating or the different workflows that we might be able to support if you're using our tools.
All right, so the first thing a RF designer, or radar designer, or any other RF system designer would do would probably to make an architectural-based system, have some requirements, and flow those through a design process all the way down to the component level. So in this example, this is a model-based design of a radar, and we build out a fully specified 8x8 phase array radar, and in this case we are flowing all the way down to the HDL design of a beamformer, and we have actually implemented the design on this AMD Zynq board, which is a ZCU111 board, and we actually deploy the design to the hardware and then integrate it back with the model. So we run basically with a hardware model in the loop, FPGA-in-the-loop we call it. And this is an example of a fully fleshed out system design from top level down to the lowest level of design, which would be the actual implementation of the design. So as an example of a design step you might take, you might want to take a model-based engineering approach to RF design. This example that we have actually shown in a webinar recently is a full front-end design for an RF system, and it goes through all the steps of designing an RF front-end from the very beginning with RF budget analysis through various stages of antenna design, power amplifier design, and finally it actually incorporates a 5G software transceiver, which is built into our software, and it would, with that you can test, in this case, which is a MIMO transceiver, and you can integrate that with the front end and do a full testing with our 5G tool set. So in our final example, I'm now wearing the hat of a systems integrator in the field, and often a systems integrator will need to test an integrated RF platform with a target generator. So in this example, we have created a target generator that runs off-the-shelf hardware, which is a USRP radio, and is controlled by MATLAB and Simulink. So this is an entire target generator platform running entirely off-the-shelf platform to basically help a systems integrator integrate and test a radar in the field.